So this is ELC 131, Circuit Analysis 1, and the topic we'll cover with this presentation are control devices. Now the control devices will include switches and circuit protectors. Now, when we think about switches, the switches are defined in terms of poles and throws. Now, I've always defined a pole as a set of contacts. And I've always defined a throw as a path for current. So the first switch we look at is called a single pole, single throw. And this pictorial shows a single pole, single throw switch. There's one set of contacts and there's one path for current in and out of the device. The schematic symbol for a single pole, single throw switch is shown here as S1. So the switch is either in the off position, meaning that there's no path for current flow, or the switch is in the on position, which means there is a path for current flow, which of course will illuminate the lamp. And the same would be true for the schematic diagram. If the switch is closed, there's a path for current, and the light or the lamp will be lighted. So when the switch is off, there's no path for current. The switch is on, there is a path for current. Now the second switch we'll look at is a single pole, double throw. And with this switch, there's three terminals. And with these three terminals, we can control two different loads. Depending upon the position that the switch is in. So we can either turn on lamp 1 or we can turn on lamp 2 depending upon the position of the switch. If the switch is in this position, current flows through the switch to lamp 2, and in this position, current flows through lamp 1. Now, representing this schematically, we would see two positions for the switch. One position would turn on lamp 1, and one position would turn on lamp 2. So if the switch is in this position, lamp 1 will be on, and if the switch is down here, then lamp 2 would be illuminated. So single pole, double throw, 2 paths for current. Now, we can also have double pole switches. So we would have a double pole, single throw switch. And in this switch, we've actually got 2 sets of contacts that are physically connected together. And we show this schematically with a dashed line showing that these 2 contacts are controlled with the same physical point. So I can open the path to 2 loads, or I can close the path to 2 loads simultaneously. Now there's also a double pole, double throw switch. And in this switch, we simply add another path for current at each contact. So in the positions shown, we would have current supplied to this point and this point. If the switch was in the other position, we would have current at this point and this point, or I shouldn't say current, but voltage applied to this point. So our switches can be either single pole, single throw, single pole, double throw, double pole, single throw, or double pole, double throw. Now, one interesting application for the double throw switch is in your homes where you have one switch at one end of the hallway and another switch at the other end of the hallway. And you can close either switch or open either switch and always change the state of the light bulb. So think about in your homes, at one end of the hall, you throw a switch up, and at the other end of the hallway, you throw a switch down, the light goes off. You can turn this switch up, the light goes on. You can go down here and the light goes off. Doesn't matter which switch you change, it changes the state of the light. And this is how that circuit is wired. That from your voltage source, we connect to the common terminal, the fixed contact of a double throw switch, and then the lamp connects to the common point or the fixed terminal of another double throw switch. So as the switches are set right now, the lamp is off. If I change this switch, the light is on. If I change this switch, the light goes off. If I change this switch, the light goes on. If I change this switch, we're back to where we started. And of course, the light is off. Now, in electrical wiring, these are what is termed to be a 3-way switch. Now, we also have switches that are momentary contacts. or momentary switches, and these come in two basic categories. They're a push button, normally open switch, and a push button, normally closed. Now, the schematic symbol for these, the P, B, and O switch, looks like this, showing you schematically that the switch is normally open, and when you depress the switch, it closes the contacts to provide voltage or current at this point. And the push button normally closed switch is represented with this schematic symbol, showing that in the normal condition, the normal position, that the switch contacts are closed and depressing the button opens the circuit. So push button normally open, push button normally closed. Now, our circuit protectors are used to protect the circuit from excessive current. That's the purpose of these devices, is to protect the wiring and or the devices in the circuit from excessive current flowing through the circuit. And these circuit protectors are in two categories. One, of course, is a fuse, and the other is in a circuit breaker. The schematic symbol for the fuse is as shown. And a fuse is nothing more than a piece of wire that heats up when current flows through it. And if it heats up, and if too much current flows, it heats up to the point where this piece of wire actually melts and interrupts the current flow in the circuit. The circuit breaker either uses a thermal circuit or an electromagnetic circuit to open a set of contacts when too much current flows. And this is the schematic symbol for the circuit breaker. And you're all familiar, I'm sure, with circuit breakers. You've seen them in the panel box of your homes. And you will undoubtedly have a circuit breaker if you have a circuit protector for your computer or other electronic appliances in your homes, that you have to push the button to reset this if too much current has flowed in the circuit. So again, our control devices will include switches, described or defined in terms of the number of poles and throws they have. And they can also be momentary switches in the case of push button switches. And our circuit protectors, which include fuses and circuit breakers.